Okay, well, hello guys. I guess I'm a YouTuber now because I am attempting to teach you through video. And those videos will be on YouTube and they'll be available to you at any point. And I think for us going forward, that's the best way. And by that I mean to start with 2019 questions and work backwards through the questions, answering them, explaining them, and trying to make things a little bit easier for you. You basically just keep working along. Practice makes perfect. And any questions you have, sure you can send me a message through the Google Classroom. What am I going to say? Oh yeah, I wanted to print out not only the question for you today, but insofar as I can in future, any questions we're doing where I can print out the question itself so that you're only drawing from a certain point and therefore learning. I will do that, but it doesn't necessarily work with every question, but it is why I have started question 5 today. Now, I think we have done this one before. I'm sure we have, to be honest. But look, at the moment, it's all about practice and keeping your hand in and keeping drawing. And every time you do a question, even if you've done the same one before, you will learn something new about it. All right, like for example, actually, I just learned that this isn't a balloon, it's a lighting company logo. Anyway, doesn't matter what shape it is. So we're doing transformation geometry. There's 4 transformations. We have to put it through: axial symmetry, central symmetry, translation. Those 3 are on at ordinary level anyway and are relatively easy. And then rotation. Now, why do I like this question? Because in terms of marks, it's a reasonably good question to get marks in because it's learnable. Now, I know that that's not always the best way forward. We need to understand things as well. But, sometimes you just don't have the time to learn it. All right, so let's get started. So I've printed the question. Look, if you can't print the question, you can always draw it out. If you don't have equipment, which I don't have actually, to be quite honest, I've only a couple of small set squares. But anyway, if you don't have equipment, you'll still be able to do it, which is another reason why I wanted to do a video, just to prove that you can. Okay, so the logo we're given is the logo for a lighting company, and that logo is made up of this, I was going to say basket, but this base section, this rectangle. So it's made up of a rectangle that I'm just going to shade in. And the reason I'm going to shade it is I'm going to follow each pattern then all the way around as I do the question. But also, while I'm shading it, I'm beginning to think and I'm beginning to figure out, well, how am I going to do this? How many points are there? Now, would I be shading inside in the exam? Probably not. Mainly because you don't have the time for this kind of lark. But if you're in the habit of doing it, then when it comes to that crucial exam time, you will kind of do it in your head anyway. You might not physically shade, but it will help you in the long run. Okay, while I was shading there, I spotted that there are 4 points. Now, points are important because effectively we're going to be moving this shape around the page. That's all. We're just moving it, but we're moving it particular directions. Okay, so when I shaded in, I noticed that there was 4 points made up the base, and then this circular top section was made up by a center point for the circle and a base point down here. Now, in this topic, and it's not the same in all of them, but in this topic, a circle doesn't really make things any harder. Okay, because really a circle boils down to 1 point that you move around following the same points that you had. Okay, so rather than worry about that, okay, I'm going to just remind you though that the circle, yes, it's as easy as anything else, but why is it in there? Accuracy. It kind of shows up your accuracy or highlights your inaccuracy if that's the case. So, mind you, having said that, I wouldn't be too worried about it keeping too accurate. You lose more marks by going wrong than you ever do by being inaccurate. Okay, so let's have a look at it. So we are asked, let me get a couple of markers here now. We're asked to do an axial symmetry. And during that axial symmetry, at the start, or at least the first thing we're asked to do is an axial symmetry. We're supposed to move P. There's P. P needs to be moved to P1. Okay, where's P1? Why am I putting colour on it? Because I want to kind of see a pattern here. In other words, I want to make this easier. That's what this stuff is all about, lads. I'm all for making things easier, as we all are. P1 then to P2. So P2. Where is P2? And here's, I suppose, the reason why I'm doing this. You might think, oh, there it is over there, but it's not. When you actually look at it, that's P4, that's P3, P2 is down here. The amount of kids that make mistakes and move it just to the wrong place for no other reason than just not being careful. And of course, in an exam, you couldn't accuse them of not being careful. In an exam, you're rushing. So, and rushing as in moving quickly, not the nationality, but you are rushing through the question. So P2 then to P3, where is P3? It's down here. And then P3 goes to P4. What colour haven't I used? All of them. Need a new colour. Need a new colour, guys. What have I? Oh, pink. Pink, of course. How did I forget pink? Anyway, P2, P3, P4. So now I at least see that I'm going to go from here up over to P2, cross to P3, back up to P4. Okay, so hopefully that'll prevent me making a mistake. Now, the reason I gave you a sheet that is covered, or sorry, is kind of centered in the space around it, it's because we're going to use that sheet now to try and explain or add notes to the question. So this is the teaching part of things here now. So back when you were fresh-faced second years, were you still fresh-faced in second year? I don't know, I can't remember. But anyway, back then, when we first learned about axial symmetry, A-X-I-A-L. And I want you to write these notes as well. 2 reasons for that. E-T, well, one, you mightn't make a spelling mistake like I might have making. But the first reason is it means you're actually engaging with what I'm saying now. That's the first thing. And the second thing is it kind of calms us down. Now, I know I've told you this before, writing stuff or highlighting or even just learning stuff makes you feel like you're getting somewhere, right? And it's all about being positive, particularly at the moment. Anyway, axial symmetry. What does axial symmetry actually mean? Well, if you remember back, I said to you, and I hope you're all chomping at the bit there, ready to shout out at me, that it means mirror image. So what you see when you look in the mirror every day. That's what we're going to do. We're going to do a mirror image of that object. Now, be very careful. Most people think translation comes first. They just seem to think it is. At higher level, the different ones can be mixed up. So it's mirror image. And that basically means we're going to take a point. We're going to move it through a mirror. And by mirror, I mean a line that is perpendicular to it. And we're going to move it out the other side by the same distance. Okay, so it goes like boom and out, and the distance is the same. That's what I mean by mirror image. So that's axial symmetry, and that's the first one we're going to do in this question. Okay, axial symmetry. Now, then we have to do central symmetry. C-E-N-T-R-A-L. Why am I spelling it? Not because I don't think you can spell, but because, hang on, I'm going to stop what I smell. Try and spell symmetry right this time. E-T-R-Y. Because look, the answer, the clue is in the name. I'm going to need a center point. So if I go back over here for a minute, we'll have moved P to P1 as a mirror image. So in other words, there'll be a line here at 90 degrees, but I'll go into more detail on that when we're drawing in a minute. P1 then will move to P2 through a central symmetry, which means a center point. So what are you going to have to do? So your job, your question mark, is to bisect from, I suppose, P1 to P2. And that point is the central symmetry point, the center point. Okay, so we'll give that an old colour. You know how fond I am of colour. So central symmetry. Now, those two are fairly easy, but they're not the easiest, because the easiest one is translation, which, as I said, be careful so people don't read the question and they don't spot that. Well, translation is not first. They assume translation is first, and it often is. Nearly always is at ordinary level, but not here for us. So we're going to go over here and we're going to do translation. What does translation mean? Well, it's another type of symmetry. I remember you'll be doing these in maths as well. I think my hanging camera there is after Starting to rock on me. Anyway, it doesn't matter. Translation means to move the shape, because that's what it is. I was going to say object, but it's a shape, really, in a particular direction move the shape in a particular direction for a particular distance. Now, let's put that in English, or better English, or more understandable for a particular distance. English. What does that actually mean? It literally means the object would move, it sort of slides. Can you imagine holding onto it and just sliding it up, sliding it down, but not twisting it? If you think back to when I did this with you first, I was at pains to get you to remember the two words distance and direction, D and D, for this one. So that's all you need to know. Once you know that, you will know which way it is going. Now, if I was starting this from scratch with you in class, I'd be explaining these a lot more. But we're coming from a position where we already know a certain amount about this. It's not totally new to us. But anyway, distance, very important, and direction. You remember that. Okay, and the last one then, let me just put my little colouredy section around there. God forbid it wouldn't be colouredy. Right, is, and I haven't much space left for it. What I have it is rotation. Now this is the hard one. This is really what makes it higher level. And as we discovered before, and I'm trying to remember now off the top of my head, I can't remember the exact amounts, but if you've answered the question fully correct up to this point, you have, I think, somewhere in the low 80s in terms of percent. And you're not over into the A grade, but you're certainly close to it. But anyway, so the last one is rotation. A little bit harder. The problem with rotation, I suppose, is, and I have it kind of in my own head as well, not only is it a little bit harder, but our brain tells us it's a little bit harder. So automatically, you kind of step back and go, oh, this is harder. So if it's harder, therefore if I go wrong, it doesn't really matter. But it does matter, because it's actually fairly easy. The most annoying thing with it is it's tedious. So rotation means to take the object, and this is where I have to stop down here now for a minute. It's rotation anti-clockwise to 90 degrees from P3 to P4. Now, you will remember, at least I hope you will, because I feel like I've said it a lot, that I said no matter what, when you're doing this question, look at what you're given. So P3 is there, P4 is up here. Draw a little sketch of what is going on. So currently P3 is down here, P4 is up there. When I say, okay, draw a little sketch of what is going on, I'm saying, right, P3 has to get to P4. Okay, it's not the other way around, it's not 4 to 3. And it'll either go in that direction, because it's a rotation, it's going to be a curve, or it'll be that shape, but in this direction, not the other way. Can't go the other way, okay? 3 has to go to 4. If 4 to go to 3, the arrow will be going the opposite direction. So let's put those arrows in and put them in nice and clear and careful. Remember too, you can draw this on your actual solution sheet, and that's great. And there's no point, or there's no bother with it. In fact, you might get marks for it if you don't succeed in finishing the question. Anyway, so that's what happens. What we asked to do, we're asked to go 90 degrees, so right angle, from P3, P4, oh, and there's the bit I haven't used. So far I've taken account of the angle. So it's rotation anti-clockwise. So let's look at the good old clock here now. So 12 o'clock, 6 o'clock, 3 and 9, sure, look. I don't have to teach you that, or do I? Anyway, clockwise, that direction, anti-clockwise, that direction. So we are to go anti-clockwise, so it's this guy. So anti-clockwise here, if I twist it in that direction, look, if there's my clock and I'm twisting 3 to 3, 4, is that anti-clockwise? No, because I'm going clockwise and going 3 to 4 forward. So the one I want is this one. This is going anti-clockwise because it's going down and back up. So this is the correct path for each point under this rotation. So if that's the correct path and that's the curve, well, you know at this stage that the center point for a curve must be within the curve, not on the outside, not out here. So my center point is going to be over here at the left. And more importantly, my center point is going to be or my rotation point, sorry, I should say rotation point, I'll get killed. My rotation point is going to be 90 degrees. Now, we need to draw a triangle, or we're going to need to draw a triangle between P3 and P4 and that rotation point in order to get it, because we don't have this. So big dirty question mark up there. Maybe not dirty, just a big question mark. I don't have that point. But now that I know more about it, when it comes to actually drawing it over here, I'll be able to. Now, I'm not going to do any more drawing on that there at that minute on those sketches. When I actually draw it in the question, I'll come and talk about it a little bit more. But effectively, I have answered majority of the question there within the notes. Okay, and the next step will be to just continue on with the actual question. So this is when I come back. Now, in a minute, I'll come back with my teeny tiny set squares. We'll see how I get on with that. An inaccurate compass, but sure, look, it's worth a go. All right, talk to you. Okay, so here goes. We're going to start our question, and the first part of the question I have to solve is the axial symmetry from P to P1, and I'm just going to try and zoom in there. The camera rocks, you'll know why. I literally have the camera suspended from the ceiling. Okay, I think that's clear enough. Yeah, that's not too bad. Push up a little bit maybe. Okay, so yeah, suspended from the ceiling, so therefore it's kind of rocking a little bit. Anyway, it's working. So we are asked to move P to P1 through an axial symmetry. Okay, just got to check that again. All right, let me just point my pencil. So first job, no matter what, okay, and at this stage I'm into what will I do if I was inside the exam, I would highlight what it is that I have to do. Now look, there's my teeny tiny little set square. You would like to see that I have as little equipment as some of you have at home. I'm hoping to fix that tomorrow though. But anyway, so P is going to move to P1. But because it's an axial symmetry, which means that we're going to be creating a mirror image, it means that P moves to P1 through a point, through a mirror, through a line that is perpendicular to it. When you look at the mirror, okay, when you look straight in at it, stand in front of a mirror and look at yourself directly. You're looking at not only a mirror image of yourself, but you're looking at 90 degrees to that mirror. That mirror is literally 90 degrees in front of your eyeballs or your view. So the first thing I have to do is draw a line perpendicular on the halfway point. Now, our method for bisecting a line anyway is lovely and favourable, because when it bisects the line, it also automatically gives me the perpendicular line. So how do I do it? I make the compass. Let's a bit of quick revision on how do you bisect a line. Compass slightly more than halfway. Scribe an arc to each side of the line. Keep the compass set as it's set, and put the compass down at P1. Scribe a second line. Okay, and where those two arcs cross, that is my bisector. It's my bisection point. But it's also even way more important than that, because it is also the perpendicular line that I need. It's my mirror. And actually at this stage, I should use the right terminology. It's my axis. So axial symmetry needs an axis. Who would have thought? So here it is, my axis line, 90 degrees through those points. And actually, while I'm at it now, just, sure, look, let's mention it. Why does that work? And I know I've told you this before, and I know I've asked you this before, and I'm hoping you're all thinking, oh, sure, she told us that. It works because, look, if I joined that point back to P and that point back to P, what shape would I get? A good old isosceles triangle. The distance of that side is the same as that side. And that's why it gives you the bisector and perpendicular. All right, so there's my axis. Okay, it's my mirror. Now, what happens next? Every point goes through that mirror out the side. Now, what do I mean? Or out the other side the same amount. What do I mean by every point? Well, we already have P. There it is, fixed point. It's going to be the same point the whole way around the view, around the drawing. Sorry, around the view. So, okay, I'm going to call this corner over here number 1, number 2, number 3, and I suppose the centre of the circle number 4. And I suppose just to make it a bit easier, even though I'm going to call it 0.5, that point there. It's not actually as important as it looks because you'll be able to find that relatively easy. It's more important that you move 1, 2, 3, and 4. Now, what do I mean by move? I mean, okay, and here's where I have to do sliding set squares with my teeny tiny little set squares. Anyway, I set my sliding set square to the green line, P to P1. In other words, the direction all of this is moving in. And I go to each individual point. So for example, if I start there at number 3, I take 3, I bring it through the axis, through the mirror, out the other side. How far out the other side? Well, I don't know yet. Well, I do, but I don't have it marked yet because it is the same distance. So compass out again. Now, I think I've already gone slightly inaccurate. Anyway, center, axis, measure, open the compass to point 3. There it is, point 3. Rotate the compass out the other side, the same distance. So there's 3 now in my new question. Now, there is a shortcut at this point, or at this stage. It's terrible how in the English language some words mean the same thing. Anyway, there's a different thing at this stage. I could use a shortcut here by going at 90 degrees, by joining 3 to P and going at 90 degrees to it, because it's an ordinary rectangle. But look, you're not going to get full marks for that, as was mentioned in the question. If you look at the very bottom of the question, look, and I think I mentioned it at the time, all geometric constructions must be clearly shown. Okay, so let's go do the same thing for number 1, and this is where things get tricky with my teeny tiny set square. So number 1, trying to keep it as accurate as I can. Through the axis, out the other side, the same distance. I'm going to have to do it twice. There we go. What's the distance this time? Point your compass along the axis, open the compass out to point 1. There it is. Swing that over. And there is point 1. Do the same now with number 2. And again, trying to keep as accurate as I can. So 2. Okay, now I might actually even speed up this little bit of the video. So 2 at the other side, and 2. Now, here's what I mean about shortcuts. Or at least why point 5 isn't as valuable a point or as helpful a point as the other ones have been. So 1 gets joined to 2. Nice heavy line because it's part of my solution. 2 gets joined to 3. 3 gets joined back to P, which we're now calling P1. P1 goes to 1. Oh, look at that. It's a rectangle, same as we had, but it's tilted against or opposite, or it's mirrored from the original. Now, how do I do a shortcut? Point 5. Because it's on the line from P to 1, I don't need to measure it because it just moves the same way as everything else did. So rather than bringing up 0.5, I can just do that. Oh yeah, look at it there where it crosses the line. There's my 5. What does 5 join to? It joins to the edges of the circle. So 4 comes up next. P1, just trying to make this teeny set square a bit more accurate. Okay, there's 4. Projected through, out the other side, the same distance. So therefore compass is out again. There's my point 4. I need to go back over here and take the center point 4 out to the edge of the circle. There it is. And there's my new circle. Whoopsie daisies. There it is. My new circle. Oh, sugar. You're up. Be grand, as they say. Sure, you'll forgive me. And then what happens to the edge of the circle? Now, by right, I should be drawing a tangent here, proper tangent setup, or at the very least finding the tangential point on this original one. But in the interest of learning about transformation geometry here for a while, I'm going to leave that as is. Okay, so 5 gets joined to the edge. So all I'm doing, I'm putting my pencil down on 5, sliding the set square or the rule or whatever to meet the pencil, and then pivoting, twisting on the point 5. Okay, so just point of contact. So now, so there is our first transformation done, and that transformation was an axial symmetry. So you have the notes that we already made on that on your sheet. So let's continue on fairly lively to the central symmetry. Okay, that's part 1 done there, the axial symmetry. Now I'm moving on to the central symmetry, which is from P1 to P2. So let me just zoom in on that for you. So P1 to P2, a bit bigger. And down a little bit. Yeah, okay. I probably need to move it again in a minute, but actually, let me zoom out a wee bit. There, that might be better. So P1 to P2. Right, what happens this time? So this time, and I should have sharpened my pencil there now while the camera was off. Anyway, this time P is going to P1. No, sorry, we did that. P1 is going to P2. And as it's going to P2, it goes through a central point. So that's the difference. The last time we went through a central axis, a line that was perpendicular to P1 and P2. This time we're going through a central point. So it's to be honest, it's very, very, very similar. The hardest thing about these is mixing them up. It's not really doing them. You know, they're easy. So P1 goes to P2, goes along this line. But the reality is it has gone through a center point. Okay, I just dropped the sharpener. Anyway, it goes through a center point, but I don't know where that center point is, but it is on the line between P1 and P2. Anything that is a center is a halfway point. So again, I'm bisecting between P1 and P2, which if you haven't adjusted what's going on in your exam isn't a bad idea to do no matter what. Get a few marks for it. So I'm bisecting. And again, the reason this is working is because I'm drawing isosceles triangle, so you know that already. So to go for bisection, compass slightly more than halfway and bisect. Now, I'm not interested in the line this time, so I'm not going giving it a colour. It's the point I'm after. So there's my 2 points. I'll just draw it in lightly, but the bit that is valuable, the money bit, the one that I wanted, or the bit of information I needed, was this dot here. Okay, that's section. That is my central symmetry point. Now what that means, and again it's fairly easy, at least this time I'm not going to need to use sliding set squares, but basically P1 moved to P2, it went that way, and it went through the central point and out the other side. So 1 now needs to do the exact same thing. Like, they're not making up a whole new routine here. So what happens is 1 goes through that point, out the other side, the same distance. So it's not a line, it's a point. That is the only difference. So point and through, and set your compass out the other side, the same distance. So there's my new point 1. Do the same with 3. Harder to keep this guy accurate now, so take your time about it. Like, keep your head about you, keep your wits about you, as they say. So 3 through, out the other side, same distance. So back up with the compass. Okay. And it's at this point I might forward this bit on a bit. So we'll see. So there we are, 3. 2. 3. through the point out the other side. Compass out again. Glad I brought my compass home. I'd lost it with that. Although it's a little bit loose. 0.2. So there is my rectangle. 1, 2, 3. 3 back to P. Now, the accurate eye amongst you will spot that this isn't as accurate as it should be, because that's certainly not a 90-degree angle down there. But you know what? I'm going to continue on. You haven't time inside an exam for fixing those little things. And it is much harder to be accurate with this. It's even harder today because I haven't big set squares. So I'm going to stick with that and I'm going to be happy and I'm going to get over it and continue on. So center point again, 4. So through, out, continue. I'm probably going to need to bring that a bit bigger. Yeah. Okay, oh, hopefully this will fit now on the sheet. It might not. Such is life. It's a whole new world with this COVID business. Anyway, 4, turn. There we go. So yeah, I can get the point in, but am I going to be able to fit the circle? It actually doesn't matter if I can't. Even in an exam, it doesn't matter because your construction is right. Oh, look, it just fits. Okay, it goes over the margin. Gosh, that's okay. So there's my circle. I lost it out with my fancy pencils. I left them in school too. All right, last point is 5. And again, there's a shortcut with 5 because you just bring it through and out to cut that other point. So let's finish this bit. Now, when it comes to you revising, by the way, yes, it's worth doing full questions because sometimes you go wrong in areas that you wouldn't have expected to go wrong in. But equally, if you know well that you're able to do all these parts, like for example, you could do a shortcut in this, those 2 lines aren't really vital at all. If you're able to do them and you know what's going on, so that's okay. All right, let me just heavy that in, shade it, and then we'll move on again to the next bit. So we're nearly halfway there. So shade it. Now, just while I'm shading, let's have a look at what actually happened. So after the axial symmetry, the shape kind of flipped over. So if you imagine, if I folded the paper there along the axis, every one of these points would end up on top of their partners. 4 would end up on top of 4, 2 would end up on top of 2, 3 would end up on top of 3. Whereas at central symmetry, it's different. The object kind of twists, it looks a little bit like a rotation, but I shouldn't really use that terminology because that's not quite right. But it does look like it. And sure, whatever helps you remember it. Okay, so there is my light bulb / hot air balloon, even though it's a light bulb. Okay, next one so is 2 to 3. So we're down here, and I'm desperately praying that this will fit, and I don't think it will. It's a translation. So translation, let's go back here for a minute. Let me just move this out of the way. There we go. Translation is, there we are, to move the shape in a particular direction for a particular distance. So distance and direction. Well, what is that distance and what is that direction? Well, it is, let me sharpen my pencil, a line joining from P2 to P3. And whatever angle P2 and P3 is going at, that's the same angle that every other point goes at. And they all move the same distance. So you can see why I'm worried now about the page. It's not the page's fault though. So here it is. My direction is this way. This way. P2 to P3. Down here along, moving along. 2 moves down to 3. All is well with the world. And the distance it moves is whatever the measurement is between P2 and P3. So I'm going to set my compass. So this particular view or this particular one, your compass is set from P2 to P3. So whatever that measurement is, I don't know what it is, I don't care what it is, because I'm setting it on my compass. I just set it. There it is. And you leave, let's just check that that's accurate. Yeah, I'm happy with that. You leave that compass set because it's not going to change. Now, what happens here? Every point moves that way. So they're all going parallel. So slide and set squares. Now, I suppose the most confusing thing about these questions is that you're kind of doing the same thing each time, but it might be the same thing, but it's different. Like here's parallel lines like we do in the first part. The last question we went through went out the other side the same distance. So you do need to keep your head about you. Now I'm just noticing with mine there, my 0.1 and my 0.3 are almost on the same line. They're nearly on the same line. I'm going to assume that they are on the same line for the sake of argument. 2 goes that way, and the last one, 4. Okay, so now that I have my compass set, this is the fastest one to do. P2 to P3, 1 to new 1, 3 to new 3. Am I still on the camera? I am. 2 to new 2, and 4, even though it's not written, 4 to new 4. Oh, look at that. It just about fits in. Enough it fits in that I'm happy. Oopsie daisies. So that's 0.4. And there's my new 0.4. So let's go put that in again. Now there is a way of fixing the accuracy in this. You could go to the bother of trying to straighten it up and make it look 90 degrees. I wouldn't bother the lads. Just keep going. So there we go. Okay, and won't be able to draw my full circle this time. The world won't end, so I'll set my compass now to size the circle. There it is. There's my center. Gone off the edge. Don't care. I won't be drawing it on my desk, mind you. Hardly going to be able to hand up the slab of a desk. Of course, you could, if you were really bothered by it going off the edge of the page there, whatever, you can add on a little piece of paper. But considering it's only just to show the rest of the circle, you're not going to lose any marks really for it. Okay, now I haven't been talking too much about marks in this question and how it's marked and so on, because we've done a lot of that in school. You know where to go to look for the marking scheme, so at least you get an idea of what the marks are worth. I'm more interested now in the next 6 weeks and whatever other time that we have. I'm more interested in getting ye practiced. The more practice you get, the better you will be. And more importantly, the more practice you will get, the better you will be, and the more confident and calm and all of that you'll be, and you'll do better as a result. Okay, so there's my new shape. Okay, the last bit of this, the rotation. The bit you typically don't like. It's not just that you don't like it, you're a bit afraid of it. Now, I don't particularly like it either, but I'm not afraid of it, and the aim is to make you the same. Okay, so I am going to pop this down in front of me now again for a minute. And the bit that is important is this shape here. So P3 goes to P4. We've already figured out, and I'm just going to highlight that because it is important. We've already figured out that, first of all, the rotation point is going to need to be in the left, and it's going to be somewhere up there. In other words, it's going to be somewhere around between that 90 and that arrow. Okay, we're intelligent, we know we can do that. And I also know that my rotations are going to be going that way. Okay, so it's the blue. And if you remember back, we looked at each point, try and figure it out. But what I didn't say at the time was, well, how do I find that rotation point? Well, the important thing here is that when P3 is joined to P4 and to the rotation point R, okay, we're going to call it R, this is an isosceles triangle because those two sides are the same length. It's a circle. They are radiuses of a circle. So if they're the same length and it's an isosceles triangle, okay, but more importantly, it's an isosceles triangle with a 90-degree angle in the corner of it, well, all I have to do to work it out is, well, if it's isosceles, the angle at this side must be the same as the angle at that side. So 90 from 180 leaves me with 90. You learned that in your maths. Divide that by 2 because it's the same this angle over here needs to be 45 degrees, and this angle over here needs to be 45 degrees as well. So you can take P3 and go at 45, P4 and go at 45. That's one way. You could also draw a semicircle, bisect and draw a semicircle, you get the point. Now that would take longer, but it would be more accurate. You could bisect anyway and go for 45, and again, you'd be fairly accurate. But look, they're all just ways of getting to the same place. They're all very similar, to be honest. Okay, so back to my question. So I need to reproduce that little sketch. That's why I did it in the first place. And I need to reproduce it here. So my first job is to join P3 to P4. I'm looking for a colour I haven't used already. I don't really have one. Dark blue. So P3 gets joined to P4. And I know I need a point in here. And I know it needs to be 45 degrees. So one way of going about that, though there are more accurate methods, is take my protractor, because I do have a protractor, and measure from P3 as accurately as I can, because I'm well aware that this isn't going to be terribly accurate at all. Not in comparison to using set squares and having board and T-squares stuck on and all that stuff. I was going to say all that jazz, but anyway. 45 degrees from the left, and I'm going to go 45 degrees from the right. Okay, so what happens now? I draw in those lines, and where they cross over is my point of rotation, which is equidistant, the same distance from P3 and P4. And more importantly, I'll be able to draw a circle from 3 to 4 with this radius that is, that is an anti-clockwise rotation. I momentarily forgot there what I was doing. I was too busy looking out the window at the people walking past. Wondering, did we get new neighbours? Anyway, okay, so there it is. Rotation point R. Very imaginative naming there. I could have called it Mary, I suppose. Jack, Pat, any of those. But it's point R. Now, here is the bit you don't like. Okay, let me go back over here now and number this. So that's 0.1, 0.2, 0.3, 4, and we know 5 is in there. I'm sure I'd write it in. Why not? We can't be leaving 0.5 out at this stage of the game. So what happens here now? Each point, okay, now listen carefully before we draw. Each point is going to be joined to R. And what has to happen then is between R and 1, for example, and the new point, which is going to be somewhere over here, okay, between the new point for number 1 after the rotation, I'm trying to create a right angled triangle. I need that 90 degrees angle that I have in there at the moment. That's 90 degrees. Okay, we sort of manufacture that. We made it be 90 degrees by measuring 45. So let me write that in there so we remember it. And what's happening, and I'm actually going to use my set square to help me, and here's the first time now this set square is helpful. You're moving P3 to P4 through 90 degrees anti-clockwise. We're going to do the same. So it's like I'm keeping the corner of the set square there at R. I'm opening it to 1. 1 gets moved through. Oh look, there's going to be my lines there, 90 degrees. Now that's not the most accurate way of doing it, but that's what we would be doing. So let's actually start with this. Now my tip for this, and you might be saying in your head, hasn't she used enough colours at this stage in her drawing? And I kind of have, but my tip for this is that you use a different colour for each rotation point, because it can be fairly tricky to keep this tidy and straight in your head. And whatever you do, don't draw all the lines in at once. So start with 0.1, there's my first line. So what did I say a minute ago? I need to create a 90 degree angle between it and R. So I'm going to need 2 sliding set squares. So R to 1. And in order to get 90 degrees here, there it is. And I draw the other half, the other side of that triangle. Okay, so I get my compass, put it at R, open it to point 1. And I draw the arc. Now, do you need to draw the arc every time? No. But I just want to show you exactly what's going on. So 1 is moving as a rotation from the rotation point R, anti-clockwise as far for 90 degrees. So there's my new point 1. So in other words, this is what's happened. P3 went to P4, look, just like that, 3 to P4, which was the same distance away from R. And 1 has done the same. R to 1, R to new 1, 90 degrees. And that's the key, that's how you do rotation. So let's do another one there. So if I go to 3, and here's what I was saying to you a second ago, use a different colour. So between orange and orange is 90 degrees, between blue and blue is 90 degrees. Between, what colour have I left? Pink. Oh, I wish I'd brought all my good colours. So I'm going to do 3 to R. Okay, 90 degrees again. Now remember, sometimes it'll be a different degree, but this time it's 90. Now, in the interest of finishing this off fairly quickly, I should be using sliding set squares, but I'm happy enough to just go like that. Okay, so what changes this time? The compass changes at each movement. So it is R to 3. I'm moving it on. Where did I put my pencil? There it is. So 3, 2, 3. And again, look at it. We're moving the same, I won't say the same distance because it's not quite the same, but we're moving through the same angle. 90 degrees, and 3 and R are the same distance away no matter what. Okay, so there we go. And that's 3, so that's 1, 3, 2 and 4 are next. So let me go with yellow. Okay, so 2 to R. There it is. I'm gonna get out my little set square to speed things up. Say this video is going to be ridiculously long. I just do it in 2 parts in order to upload it. Anyway, I'm new to all this YouTubing stuff. Compass again. Compass at point R. R to 2. There's that old English language, same word problem. Rotate again. And remember what I said a while ago, you don't always necessarily have to show the rotation lines. The key is the point. You get the marks for the point. So that's number 2. And then number 4 to finish with green. I haven't used green yet, have I? No. So 4 to R. Back out again with the 90 degrees. I'm going to need to extend this line this time, it's not quite long enough. So there it is. Add my extension. Anytime you're adding an extension, keep your pencil on the line, slide the set square to meet it. Okay. And again, compass R to 4. And there's my new 4. Alright, so let's put in point 4 there. So there's my line for 4, there's my new 4. And I just hadn't drawn in the curve. So R to 4. Okay, now, so So we have nearly everything we need to answer this, even though it went off the page a little bit. But you might forgive me that. So what happens, as usual, 1 joins to P. Let me just zoom in a little bit on that. There it is. 1 joins to P. 2 joins to 3. 1 to 2. P to 3. Okay, there's my basket, and as you can see, it has gone quite wonky. I still get marks for it. It's okay. At this stage, to save me time for number 5, so there's a shortcut every time at number 5. Easiest way to put it in, set the compass. Hope you can see that there. Compass from R to 5. There it is. Rotate it. And there it is, because it's always on line P to 1, whatever the P is. So there's my 0.5. And now I set my compass again to circle 4. You can probably hear the piano in the background there. Maybe you can't, but if you can, my small ladies are doing their piano lesson through WhatsApp, which is a very strange experience. These are different times. Okay, so there's my circle. Not as tidy as I would like, and definitely not as accurate as I would like. But anyway, right, we're nearly done. The world isn't going to end, certainly tonight, because of inaccuracy. Don't know about COVID, mind you. Okay, I don't really mean that. There's my 5 there now. Alright, so there's my shape, finished. As I said earlier on, not as accurate as I would like, but we're getting there. And it's drawn. I have full construction done, so whatever about the inaccuracy, and I know you're sick of listening to this from me, the important thing is to get it done, to get the points in, to get it detailed. And of course, before I leave any sheet, I need to write down what it is and what I've been doing with it and so on. So let's add a few notes, because there's no point leaving it blankety blank like that, because you come back and you look at it again and you've no idea what you're doing or where you were going. So the first one was the axial symmetry. And that was P to P1, which is there. Then we went from axial symmetry over here to, oops, I'm not shaking my camera, central symmetry. And that is P1 to P2. Then over here, we did translation. Your favorite, easiest. Translation. That was P2 to P3. And up here we had rotation. Okay, rotation on its own is not enough because it was anti-clockwise through 90 degrees. Okay. And more importantly, this was 2019. Last year's junior certs who thought they had it hard, but in comparison to this year, it's quite different. 2019, higher level, HL, question 5. And question 5 is at higher level, and probably always will be. Well, actually it won't because the new junior cycle, but anyway. But at the moment, question 5 is always transformation geometry. And transformation geometry, please don't get the name mixed up with translation. Transformation, to move and to change. T-R-A-N-S. And of course, down here, put your name on it, or somewhere. Now, if we were in school, of course, we'd have a proper lined out sheet and I'd be using guidelines and all that stuff. But anyway, and today is 21st of April. So name it and claim it. By naming it means that you are, well, not that it means that you're proud of your work, but it shows that you're proud of your work. All right, so that's the end of that. I hope there's enough detail there for you to be able to do it. I hope there's nothing too confusing. If there is, you might let me know. Or if there's any way that I can improve these going forward. I don't know, are they clear enough or not? To me, they feel clear. But of course, I'm not the one at the other end of a camera trying to do this in third year. I will photograph both of these pages, the finished question page as well as the original question page. And I will post that as well with the questions, so at least you have a finished solution too. And of course, do not forget that on the drive I gave you access to all the, or at least I uploaded all the past papers and all the past marking schemes, and the marking schemes include the solutions. The only issue there, of course, is that the solutions might be there and they're done, but it doesn't always tell you how. All right, so look, I will talk to you again the next time I come on. It'll be another 2019 question. I don't know which one yet, whichever one I can work through fairly easily, but that's what it'll be. Okay, good luck with that, lads. Bye-bye.